There isn't an awful lot that you need to know about Venn diagrams to use them. One thing you need to know is that there is a universal set, and that represents every single element that is under consideration. Inside the universal set, you will have circles. And those circles represent sets, a set of elements. We'll call this set A. Let's pretend that A equals A, B, we'll have an element, I don't know, 12, apple. So this is a very peculiar set of random things. And we could put the elements themselves in this set into the circle. Like we could say A, B, 12. But it is more useful to put the cardinality of A into the circle. The cardinality of A is the number of elements that are in set A. So there's 1, 2, 3, and 4. And that would be, wait, let's cancel these, 4. That is one of the more useful ways to enter your data into a Venn diagram. Let's look at some Venn diagrams. Okay, so set A in the top left, that represents all the different areas, which I've numbered for you, in set A. So this area, and 4, and 1, and 2. This list here is a list of all the different ways that you can say the complement of A, which is every element that is not in A. So that represents all of this, which is area 8, as well as area 7, 3, and 5. In the bottom left, we have this symbol here, which you could say it as A and B. It represents the intersect of A and B. So the intersect would be area 4 and area 1. In the bottom right, you have this element, or this symbol, which represents A or B, which is the union. So that would be 6, 2, 1, 4, the union of A with B. So that would include 7 and 3. Okay. In the top left, if we had an element, or if we had C minus A or B, then you would actually just take away 2, 1, and 3 from all of C. So it would represent just that portion right there. In the top right, we could state this if we were to convert it into symbols. We could say maybe this would be, say, A and B. Unioned with C. That would work. In the bottom left, we could say that this, maybe you could represent it as A and B, which is this intersection, unioned with A and C, which would be this intersection. Okay, in the bottom right, which area numbers should I color in? Anyone know? Can anyone beat me to it? If not, I'm going to be pretty quick, and I'm going to do it. It is 1, 2, and 4 is correct. So these two equal. We call that an identity. Okay, now I'm going to show you how to fill in a Venn diagram. So if we have 36 people in our universe, we would put that outside the box, outside the rectangle. That will be important. So imagine 17 people study algebra. We'll call the universe 36 people, so students. 17 will study algebra. 20 will study biology. 15 calculus. 8 will study algebra and biology. Okay, so that would be 8 represents all of that area. So we can't actually put that in yet because we don't know the proportions. So what we can do is put in the 3 people study algebra, biology, and calculus, right? 3. And now we can go back and put in our 8, which is simply, so 5 there. And then what do we have? We have got a 5 to plug in, which would be 2. And now it's simple to fill out what A is, because 17 minus 5 minus 3 minus 2, that would give us 7. Unfortunately, we can't go much further, not without a little trick. And if you think about what we need is this area. We gotta find that area. But we can't in itself. We don't know the proportion. We can find this whole area though. That we can do. And the reason we can do it is think about what C plus B is. If we were to say, well, I'll write it like this. C, and I'm talking about the cardinality of these, right? So C plus B, cardinality. If we add those, then we have to minus one of these because we've actually added them twice. So let's minus the intersect of B and C. So, and it's the cardinality. And what will that equal? If we do that, it actually will equal the union of C and B. And it's the cardinality. Okay, now this is good because we know this, we know that number. We know this number. This number, we don't know. We don't know that. But we can find this out. Think about what it is. It represents, it represents all of this and all of this. Oh, wait, I missed one. See that one, right? That one person that's not studying anything? It's a strange school, I know. That one person we would put on the outside of all of our different sets. So all we have to do to figure out what A or B is take our universe minus the 7 and then minus the 1. And that's it. That's all we would have to do. So if we do that, so (36 minus 7 minus 1). What is that? 28 in a different color. So if we were to move this equation around, you could say C intersect B equals, what does it equal? Negative 28 plus 15 plus 20. Type that into your calculator. If you can beat me, then we should get 7. Is that right? 7. Yes, everyone got 7. Okay, perfect. So that means that, do I erase? This area here represents 7. I know you can't see it well, so let me do this. That area represents 7. So we would put 7 minus 3, which is 4. I know you can't see it very well, but that's a 4 right there. And now we've completed our Venn diagram. Okay, So here's a couple questions that we might answer. So how many students study algebra and biology, but not calculus? Well, we could just read it from the Venn diagram. It's easy to say that that right there are the only people that study both algebra and biology and not calculus. So the answer is 5. How about this? The probability, and we've just learned about this from Kylie. So what is the probability of someone who, if you were to randomly select a student who studies algebra but not biology? So that portion of people is this right here. So 7 and 2. So the probability of this event, we'll just call it E for whatever event, would be 7 and 2, which we learned. What did she say? NA over N. So it's 7 and 2 over the total amount of possibles. And the total amount possible is 36. Okay. So what would that equal? 9 out of 36, which is, and that is our probability. I was going to quickly show you, this is what makes Venn diagrams very useful and beautiful, I think, is conditional probability. And imagine that we were to ask, we want to select someone who studies calculus given that they study algebra. So the probability that they study calculus given algebra. That should be. So normally you would use a formula for this, but I'm going to show you you don't need a formula. All you have to do is read it from the Venn diagram. And you could do that by saying, okay, well, the amount of people that study algebra and calculus are right here, right? So that's 5, and that's going to be our numerator. But it's out of how many people? It's out of the people that study algebra, which is 17. You don't even need a formula, which is great. I'll show you the formula just in case you're curious about it. So like this formula would be, so the probability of C, the intersect with A over the probability of A. This is normally how you calculate it. Anyway, that is my presentation. Does anyone have any questions?